Hey, Wages World, what's happening, guys? Kool-aid Krew, what's crack-a-lackin'? Hey, everybody, somebody give me a 5 for 5 as I get going here. If you could, please share this out. That'd be much appreciated. And leave a like, share, subscribe, all the above. We'll get into why I haven't been here for a few days here after we get started here. But, guys, what we're going to be going through today, we've had some, we're getting hit right now with some space weather, as you can see right here. This is our magnetosphere. We got solar wind coming in from the sun. This is the speed, and there's your density, and here's your magnetic pressure. We're going to be taking a deeper look at this. You can tell that we're getting hit right now just from looking at this one model. But anyway, also, guys, we're going to find out why we're getting hit with that, where it's coming from exactly on the sun. That big eruption right there, I don't think is going to hit us, but there's been multiple other eruptions, as you'll see as we get moving through here. Now, this coronal hole right here is what's responsible for the increased space weather right now. And so, yeah, that's where that's coming from. Now, as you can see, we also had a bunch of filaments releasing. We had a very big one the other day right down through here. And this is why I haven't really been here for a minute. And the reason why, I had lots of stuff, and again, I'll go over that here in a little while. But we haven't really had anything hitting Earth. And so I wasn't like urgently having to come out here and tell you guys anything. But anyway, also, check this out. We're going to be going over this. Dr. Tony Phillips reported on this over at spaceweather.com. This is trimethyl aluminum clouds over Norway. Okay. Yeah. And we'll go over what caused these and why they're there. It is an isolated thing. So don't nobody get freaked out like it's something changing in our atmosphere or anything like that. I'll give you a little bit of a spoiler here. It's because there was a rocket launch. Okay. So we'll go over why these showed up and how they were made here in just a few minutes. But also our X-flare chances are about 25% right now. We've had an almost X-class flare the other day, right here. Well, not that one. This was back here about 2 days ago. It was a 9.8 or a 9.98, something like that. Like 100ths or tenths of a point away. Hey, good to see you, Planet Hermit. Thank you for the super chat there. That's his monthly super chat he gets. So thank you. Thank you for that. And thank you. Just thanks for being here, guys. And I know I haven't done a members only stream here in about a week. Actually, it's been about 2 weeks now. I've got unexpected things happen this week. And I'm not going to go into big detail about that. I just want you guys to know I just couldn't be here. It was impossible for me to do it. So I'm just going to kind of leave it at that. I don't, well, we can talk more about it on my members only stream. I'm going to try to do one tomorrow. Tomorrow evening, maybe even during the day. It's just so hard with my schedule right now. My daughter had senior pictures, and she's got a lot of stuff going on too. She's been getting a lot of college stuff coming in the mail. She's going to be going off to college. She's getting a lot of stuff with yeah, grants and doing all that mess. You guys know how it is. Anybody that's ever had a kid doing that, everybody understands. It's a very stressful but awesome time. So I'll just leave it at that. Now, okay, so guys, we're not in geomagnetic storm right now, but we are getting hit as we're speaking. Okay. And let me stop one more time here, guys. If you guys could please share this one out. Every time I'm gone for more than 2 days, things just really, really are slow. And I want everybody to hear me. That's why I'm here, right? I want to share my stuff with everybody. So please share it out. And I get it. I don't expect this video. I'm not really even worried about views and stuff. It's not like that. I just want people to hear what I got to say. So that's what I'll say to that. But yeah. So let me highlight that in there for you. Planet Hermit. Let's see. Oh, Planet Hermit, you're awesome. What are you doing there already? Listen, man, Guys, please understand when I talk about memberships, I don't expect that, okay? Um, it's enough that you're here. And I'm not just saying that. It really truly is. Sharing and stuff like that, yes, I really love the fact that you're able to gift memberships. I really am. But I just want everybody to know that it's not an expected thing, okay? But whoever got those, please tell him thanks. Hey, Stephanie, hi, wise Jen. And I will stop in a little while and talk to you guys, but I want to get through the space weather stuff here real quick first, okay? I just want to make sure. Hey, Jerry, because every time I'm not here for a while, people get worried about me, and I so much appreciate that, and I feel bad. Whenever that happens, I feel horrible. But, sometimes we just can't stop it, we got life, right? I mean, I hope everybody can understand. And thank you, Planet Hermit. You're such a great support here. You really, truly are. You're a blessing. I'll just say that. So, my wife says that to me every day, and I try to tell you guys that from my wife every day. Every one of you guys are a blessing to me. You guys have no idea what kind of hole you have dug me out of. And I'm talking mentally. I'm not talking anything else. When I first started this channel, I was in a very dark time of my life. And you guys and my immediate family have really, you brought me back to who I am. And I even get kind of emotional talking about it, but I'm so thankful. I really, truly am. If I only had one of you guys here listening to me, I would still be here. So just know that. So, but with that being said, I do have a goal. I want to get the initial goal is to get to 100K. I would love to have a YouTube play button, and it would be because of you guys, and that would be so awesome for me. So much stuff happened in my life I had no control over. I got hurt and stuff, and I couldn't do my factory job anymore, and I was there for 20 years, and that, like it or not, that's how I identified. I was a backup supervisor printing technician. That's the first thing that would come out of my mouth when people would introduce me. I was very proud of it, and I still am. But when that's yanked from you overnight, yeah, you have to find yourself again, and you guys helped me do that. So thank you. Anyway, so we got the magnetosphere here, and you got space weather going from left to right. So the sun's sending us high-speed solar wind. How do I know that? Well, we could come over here to the data, and I'm not going to stay a whole lot of time on this because this is boring. Graphs are boring. Let's just say it. That's one thing you're going to get here is just, if it is that way, I'm going to say it. It's not going to be biased one way or another. I don't have any loyalty one way or the other. I'm just on the side of the truth. So here we are. Now, every time you see this red line, that's the BZ. And this is very, very important, okay? This is, in my opinion, the single most important factor why we get geomagnetic storms during certain times and why we don't. Okay, this can deflect things and it can draw things in. This right here, in my opinion, controls almost all of it. And what it is the magnetic polarity, basically the direction our magnetics are in our magnetic field, okay? So when the CMEs and the solar wind comes at us, if we couple with the magnetic fields inside of those, we draw it in. And when we don't, it's just like taking two refrigerator magnets, or small magnets, or big magnets, whatever you want to do. Put positive and negative together, what happens? They snap together, right? It's hard to pull it apart. So when you got opposite polarities, so if we're in a negative and the solar wind is in a positive, what happens? They're drawn to one another. It draws it in, and it draws it in on the poles because our magnetic field is like a slinky around the Earth. Okay, our magnetic field, that's what our magnetic field looks like. It's made up of a bunch of magnetic field lines, and they're looped like that. So the further away from the poles you get towards the equator, the more space you have between the surface or the center of the Earth and the top of that magnetic field line. The stuff comes in easier on the poles because of that. One of the reasons. It's magnetics drawing it to the north or south. And it's one big magnetic circuit. So when we get hit with CMEs, I had this question the other day, and I didn't really go too much into detail, but when we get hit with CMEs, coronal mass ejections, plasma, okay, from the sun. And what is plasma? I haven't said that in a while either. Plasma is nothing more than a gas that has a charge. It is the fourth state of matter. I can't remember when they decided to call that a state of matter. I think it was when right before I started school, like 50 years ago or something. It hasn't been like hundreds of years, right? So you got solid, liquid, gas. We all know those three, but they added that fourth one. I can't remember when they did, but it is plasma. It's gas with a charge. And that's what hits us. When it's moving high speed, it affects us magnetically, right? And the density of it too. If you've got more particles hanging around, obviously it's putting off more energy. That's just pretty much how it works. So when we draw it in, we get hit with the CME, it hits us globally. This isn't something that is, just specific to one spot when we get hit. When we take a flare, and let me show you that, it's measured by X-ray. A flare is going to hit you on the day side only. Okay, the dark side of the planet isn't affected by that flare very, very little. Okay, so where you see this absorption, the D region, we'd look for like the bullseye patterns, right? And I'll probably be able to show you one here. You can kind of see it there even. So when we get into the more powerful flares, it starts to light up right there. And it affects radio propagation. That's one of the first places we notice a flare. That's one of the biggest reasons we even talk about it. Okay? Radio propagation goes down, makes first responders' jobs really, really hard because it makes them struggle with communicating with one another. So as you can see there, right there. Now I had somebody make a comment, well, this stuff never affects us. Well, yes, it does. It's just you don't know where to look, number one. Number two, you have to also figure that 70% of the planet is water. So just numbers alone is going to tell you that roughly 70% of the time it's going to happen over a body of water. Okay? And there's not a whole lot of things happening out in the middle of the Pacific unless you're Kathy. She's over there saying aloha to us. Aloha, sister, if you're here. I'm not sure if you're here or not, but yeah. So that is, it's kind of how it all works, right? So we have to keep that in mind. And I know I just I bet I answered a lot of questions with just that little bit of a rant, because I get asked those questions over and over and over again, and they're very legitimate questions. They really are. So, because people wonder. So when people are out here saying this is happening, and then nobody shows them where it's happening at, what do you expect them to think? They're not going to think anything's happening, and they're going to think people are out here crying wolf. Well, that ain't what's happening here on this channel. I can promise you that. If I'm going to say it's happening, I'm going to show it to you. So I'm showing it to you right here. And, X-rays affect radio propagation, which a lot of first responders systems, they use that for communication. And I use the example of maybe a family member has a heart attack. What if a flare happens on the day side of the planet and it's affecting ham radio operations and it slows down the ambulance? Are you going to like that? No, you're not. So it's affecting real things, real people, right? And a bigger flare does a whole lot more. And I'm not going to go into all the stuff a flare can actually do, but you can see this is how it hits. Always on the day side. But a CME, when it comes in on all those magnetic field lines, not just on the day side, because we kind of get surrounded by it, right? Like right here. This magnetosphere, this is our bow shock, okay? Solar wind's coming in from the left to the right. It hits our magnetic field, and the reaction of our magnetic field being hit by solar wind causes this magnetosphere. That's why it tails out this direction. Okay? So with that being said, you can see how we're always surrounded by it, and our magnetic field is always fighting it off. And inside of our protection, things are going to be less active, right? And you can see that very clearly here. See how the colors are lighter here in the middle? And this is just speed. This isn't anything but speed. And I can take you down here to the density, and you can see it even better. Now, it's hard to really get a good idea of what you're actually looking at when you're trying to show somebody something that's three-dimensional, and this is a two-dimensional model, right? So you have to have kind of a little bit of an imagination, but also understand that's Y and that's Z. This right here, BZ, right? Z. So that's north-south, magnetic orientation. So when we're looking at this, the Z is that. We're looking at the Earth from the side. This is a side cut. See how it's kind of pointed into the north right now? If we go look at the actual data, look what's happening. We're starting to point up now instead of to the south. And we can see that in the model. The Y is actually from top down. Okay? That is the advantage of a two-dimensional model, because you can use different axes and see different things, right? From different points of view. But you can see the waves of energy coming in here. But this is created by our magnetic field and solar wind hitting it. That's why this thing is even here. That's our bow shock, first point of contact. And you can almost even see we call it like a double bow shock phenomenon type of thing. If you look at it, you can kind of see two bow shocks, right? Well, you get that first initial hit, things kind of slow down and move, and then as it's rolling either to our side or over top or below us, it kind of creates this other bow shock here. Okay? And I'm not going to get into detail because there's a lot of levels here that we can really get into. And you can see these waves coming in really well today. See that? You can just see them just kind of rippling in. And this is exactly what you would expect from a solar wind stream. And that's exactly what we're looking at. What's a solar wind stream? I get asked that a lot too. And I know I'm answering a lot of probably basic questions for people that have been around for a while. But a solar wind stream is created just initially just from the sun being there. It's always putting out wind. The only way for our bow shock to go down, because you'll hear people say that all the time. Our bow shock never goes down. The only way that bow shock is not there is if one of two things happens. Either, guess what? This thing has to go completely away, right? Or our magnetic field has to go completely away. Or both. And guess what? If any of that happens, it's a really bad day for all of us. So, that's what I'll say. It'll be the last bad day you have too. If any of that ever happens. So, I just want to make sure that that's crystal clear. Now, this is a coronal hole. This is black on this particular model, and it's from our point of view. This is SDO, always looking at the sun. Okay? But it stays over the same part of our planet at all times. The satellite does. Basically, I'm just going to use generic white sands. That's where it sends its data back down to. Okay? Western United States. This satellite does a figure 8 pattern over that area at all times. But it's rotating, it's orbiting Earth at 15 degrees an hour, which is the same speed that we rotate around our axis. So it keeps it over the same part of our planet at all times. But the satellite also rotates itself to keep its eye on the sun at all times. Like the all-seeing eye in Lord of the Rings. Okay? So that's how I kind of explain it to people. But this is black. Why is that a hole in the sun? No. That's a hole in the atmosphere of the sun, in the corona. So that's black for a reason. This model shows things that are colder, black. And guess what? The surface of the sun is colder than the atmosphere. Yeah, figure that one out. Yeah, they're trying to. And the Parker SP was a satellite they sent out there and kissed the sun. Right? They got it into the atmosphere of the sun, first time ever. And they got some really good data out of it. And the satellite's still out there. And they're sending it back in for its closest approach on Christmas Eve this year. So we're going to get some more data to look at, which is very cool. I would love some definitive answers on why the corona is hotter than the surface of the sun. Because the heat source is the surface, right? So how does that work? You know, I don't know. We're there's a lot of good theories, and they actually probably have it pretty close to figure it out, I would assume. I've read some of them, and I'm not going to get into detail because they do get kind of complicated. It's a lot of bouncing back here and there in different parts of the atmosphere. And, you know, so if you want to learn that, all you got to do is Google it or DuckDuckGo it or whatever search engine you use, and you'll get there. But so when the corona opens up, what happens? It exposes the surface of the sun, and the sun just starts spewing out plasma, our direction. Okay, we will connect to that magnetically. Everything in our solar system is connected to the sun. If you were out there, and I've said this 1,000 times, you guys could probably type it in there before I even say it. If you were out in space, butt naked, your left butt cheek would be connected to the sun magnetically. Every satellite, everything is connected to the sun. Okay? By an interplanetary magnetic field line. Now, I also want to point something out here, too. Okay, now this matters. People ask me about planetary alignments all the time. Okay? I want to tell you right now that every planet in the inner solar system is on our side of the sun right now. That matters, guys. And if you're looking at this model right here, this dashed line, those are the magnetic field lines that connect us to the sun. Here's Earth, this yellow ball. These are some of the satellites. That's Mars. That's Venus. That's Mercury. Okay? This is showing you CMEs blasting off of the sun right there. See that? There's actually 2 of them on this one, which is actually kind of an oddity for the NASA model. Usually it only shows you 1 at a time. But this one, they've got 2. Notice where all the magnetic field lines are. They're all on, you know, if you draw a line half, they're all on this side. What's that mean? Well, it means everything magnetically is being drawn this way. Okay? I mean, the chances of that is just what it is, right? Now, I don't know if, like, the outer planets are, like Jupiter. I don't know where they're at right now. We could go find them. But right now, the inner solar system, all 4 planets here are on this side of the sun. And yes, that does affect the sun. Okay? And especially when we have line. You see this right here? See these 2 planets? What happened right there? You guys see that? I don't even have to say it. I mean, and this happens often. Not every time. This is just one thing that could kind of help the sun instigate a CME is planetary alignments. Oftentimes when we see bigger eruptions, or eruptions when you don't expect them to happen, they'll be involved with the planetary alignment of some sort. Okay? And I don't usually go too much into that because it does get kind of repetitive. But it's also, I would have to show you a lot of data to really hammer that point home. So, yeah. Now, guys, can you guys give me a roll call in there? I would really love to know, just regional. I don't need anything big or anything like that. Like exactly where you're at. I just want to know kind of regional where you're at. Hey, Akila. What's going on? Hey, Jeff Will. It's good to see you. But yeah, guys. So, yeah, give me a roll call in there if you could. But I also want to stop and say thank you again to Planet Hermit for the 20 gifted memberships. You're awesome. Thank you so much. And I'm going to be making up a lot of those. You're probably going to catch me on a week where I'm going to do 3 or 4 members only to make up for everything. I plan on giving out some cards. I got some bicycle playing cards, discontinued boxes of them. My wife found them, and they're called Sunspot, believe it or not. They have a whole line of cards that they put out. Bicycle did. They're high quality. I sent them out to some people already. They want them on a couple of the other giveaways that I did. But yeah, so anyway, so where we got? Northeastern Nevada, North Carolina, Central CA. What's up, Pixel T? Kristen, good to see you. Western Washington. Tony's from North Carolina. John's from Northeastern Nevada. Oklahoma. Renee, what's up? That guy ain't seen you in a minute. What's up? Directly above the center of the earth. Good answer. Central Wisconsin. That's right, Wise Jen. You the man. That's or woman or woman. I can't remember everybody's gender. I can't. I'm horrible with that, guys. I really am. Hey, Trish, good to see you. Southern Nevada, social media. And I've even asked you more than once, Wise Jen. I know I have. I know I have. And I still forget. It's horrible. Don't ever get old. Well, yeah, please get old, because the other option isn't all that great. Like that's right, baby. Hey, Allison, good to see you. Marfuga, hey, Marfuga Barn Grill, good to see you. Olympia, Washington, baby. Canada, no. Hey, I got some Canucks in here. Is Axe in here? You guys don't know Axe and Nacho? Get up there and check them out. Axe and Nacho, they're in my awesome channel list. Go look it up, please. Hey, I could use one, so I'm looking at. Oh, are you? I know you were losing one of them. I didn't want to say it here, but since you did, I guess we could talk about it for a minute. Guys, Miss Dragon has got, you know, the big C, and she's about ready to lose, like she said right there, her twins. So let's get some ones in there. Let's show some love for her, all right, guys? I want that whole chat just to light up with ones. That'd be awesome, guys. Please. You know, I know it sounds ridiculous to some people, but let me tell you, just that can kind of brighten somebody's mood, and if you can do that, it's worth it. And she is awesome. She's one of the managing moderators here on the channel. She sent me a pyramid that's purple. I'm going to be showing it to you. It's purple and gold. It's beautiful, number one. She made it. So I'll be showing that to you guys, okay? Here in the next couple days. But yeah. So we always got to pray, guys. Prayers and good love, thoughts, whatever you do, right? We don't need the negative stuff. We just want the positive stuff around here. Hey, Stephanie. Hey, Ron. Good to see you, bud. Get over and check out Emergency Management too, guys. Earthquake stuff, guys. He knows what he's talking about over there. Get over and check out his channel. He goes live every time there's something big. He does daily reports. It's good stuff. Get over and check him out. He's on my awesome channel list also. He's a good friend of mine too. So we're just going to leave it at that. All right. Now, and Mist, you know I pray for you all the time. Just so you know. I'm just going to say it again, just in case you didn't hear me the first 1,000 times I've said it. That's how much we love you. So, and guys, as much love as we're giving her, she gives it right back. I promise. I promise. So get over and check out her channel too, guys. Nothing but positivity all the way around. I promise. I won't send you somewhere negative. That's a negatory here, right here. So, Trish, thank you. You're awesome. Thank you. So appreciated. I can't even, you guys see, you know, I'm blessed. And that's exactly what I'm talking about. And guys, you guys don't, and I get emails daily, just so you guys know. Okay? And moderators, go ahead and show those, please. I usually don't show a whole bunch of emojis because the algorithm doesn't like it. But when we're asking for good thoughts and prayers, please let moderators just go ahead and show those when that's happening. Hey, Verti, I seen that you were sick. I didn't even know you were sick, man. I'm glad you're back here, man. I really am. He needs it too, guys. I mean, there's so many people, and that's why I don't want to come here with my issues, because my issues are nowhere near what they're going through, okay? So I'm not going to come here with that. I'm just going to tell you, hey, I had stuff going on, and that's all. That's where I'm going to leave it, okay? Because we don't need to be hearing my stuff when people out there are going through that. So, just so you know. That's why I'm not going into detail. Now, when we get over to the members-only stream, I'll share a little more, okay? But right here, that's all I'm going to say. Hey, Daryl, good to see you, bud. Awesome. Allison, what's up? That's right. I love that. That's awesome. Yes, he is social media. 100. By the way, guys, if you are a member, please use those special member emojis that you guys are, that's what you guys can use. Nobody else can use those but you guys. Anyway, okay, so back to space weather. Sorry. Guys, check out this filament that erupted down here. I'm showing you this one because it's showing this particular angstrom of light. It's the 193 angstrom. it filters out all other light. So it's looking at a specific gas, and I'm not really sure what gas this is. I need to find that out, and I say that a lot. I just forget to do it. But we look at different angstroms so we can get different visuals, so we can understand what's happening better. Okay? So when you look at this is one of the most impressive filaments down here, and I'm going to zoom in a little bit more, that I think I've seen in quite some time. And I'm not just saying that. This thing will stretch from here all the way over to here. See, it's right here. Watch it release. Watch this thing. Oops, I kind of just blocked that, didn't I? What a moron. I just blocked it. At least I think I did. I don't know, did I? We'll see. We'll watch it again. It's going to come back through here. Actually, I'm just going to pause it. And we'll just drag it back right here. We'll just do it this way, okay? So you guys see this. This is all connected. I know you can't kind of see it here, but the sun's actually camouflaging it itself because it's the background. You see how this is all standing up? Now remember, this isn't like wind on our planet. Low pressure rushing in to fill out high pressure or vice versa, right? You know, put the drop top down, go cruise down the highway, that kind of... No, it's not like that. What you're seeing here, you're actually seeing magnetic lines. Okay? And you're seeing the highly charged particles, plasma, traveling on that line. Why does it look like it's swirling and things like that? Because that's the actual shape of the magnetic line. It's just what you're seeing, the movement is the charged particles staying on that road, right on that line. That's what's happening. Okay, so the plasma doesn't leave those magnetic lines. So watch what happens. It appears to swirl and everything else, and physically it actually is moving in a swirling motion, but it's not spinning like you would think like a tornado does. Okay, so just notice how big this thing is. That is a large one. This is almost up to the middle of the sun. Look at this. And it's actually even touching almost around the backside. That's like almost, if this was all on the front, it would stretch all the way across the whole front of the sun. This is a large filament. So, as we get moving here, you see this other eruption back here? Check that out. That's on the backside. Now see, that one was even cool too. You see the shape it took? And again, that's not wind. That's magnetics moving. So, and I know that that's hard to understand. I really do. Because first time hearing that, it's hard to kind of visualize that. But as I move this, you can actually even see the magnetics moving here if you zoom in. If you're on your phone, you probably can't. But as you can see, this is lifting off. It's snapping right in the middle. See that? Now you're going to see a lot of this goes back down to the sun. And that's exactly what you would expect. Magnetics pulls it back. So yeah. Okay. Yeah. Guys, Axe and Nacho are going to go live here in about 5 minutes too. So after my show, get over and check out Marfugal. And get up there and check out Axe and Nacho. Please. Anyway, but see how this kind of streamed out right there? Look at that. That's a lot of plasma, guys, and I'm going to show you a different angstrom here in a minute. But you see how we even had what we call a cannon of fire open up. It's not fire, okay? You see how this is kind of not opened at all, right? The atmosphere. Watch what happens when this filament rips off. It pulls enough plasma off of the sun, off the corona, that it almost exposes the surface right there. Watch what happens. You see that? Right there. See how it get bright in that area right there and kind of right down the middle? You see how it's kind of darker? See that? The sun's amazing. I mean, look at what it does. And that's why, this is why I enjoy this. This stuff is really cool to me. But this was a massive one. Now, I have to say, though, I do think that we're lucky it didn't happen up here. Because it would have been coming right at us. This thing here may still give us a glancing blow, and it's still mainly going south. It's most likely not going to hit us at all, but it could give us a glancing blow. I don't think it's going to, but it's possible. So let me zoom back out a little bit. Okay, and what we'll do is we're gonna look at a lot of these eruptions since the 11th. So this big hole, we're connected to that right on the 11th back then. So we're gonna have this wind for 2 or 3 days. It takes solar wind about 3 days to get here. If it's moving fast, it can get here in less than a day, but those are usually from CMEs. Now, right there was the big one. Now, notice that, see, even up here where my cursor is, top left, see how we had a little eruption right there? That ain't coming at us. We had a bigger one up here today or yesterday. Okay, yeah, did you see that? That one there, see how fast that moves? Now, we don't get to see a whole lot of it, but the reason why is because it was so violent and fast. Watch. See that? And then it's out of there. It's gone. And then another pop. And then another one here. Now, that one was a big one. And that was mainly on the backside. That is not going to hit us. Okay? But that thing popped, and it popped fast. Watch it. Boom. Look at that. That's exactly what this one did down here, except this one here was probably double the size than that. So that's how powerful those things can be. I just want to make sure you guys are seeing that. So, but yeah. Hey, Dustin, good to see you. Yeah, Axe and Nacho. Axe is my friend. He's the dude. Nacho is the girl, if we want to go like that. I don't know if they want me using their real names or not, so I don't. Just so you know. They're one of my favorite Canucks, if not my favorite Canucks. Lord Kiss Freaks is one of my favorite Canucks, too. Alright. So, with that being said, guys, those are not going to hit us, but we do have some that possibly could. And, one of the best ways to know if we're getting hit is this. Aurora. So we always watch this. So it doesn't look like we're going to be seeing a whole... They're not forecasting a whole lot here. But, you know, is what it is. Now, we did dip back down to BZ as we were doing this live stream. Every time we get to -6, and that's the threshold we're looking for to really be drawing stuff in, they'll highlight that in this lavender color. Whatever your display shows it as. For you, I'm not sure. Mine's showing it like a purple or lavender color. When we're in that magnetic position, we will draw stuff in more. Now the opposite's true if it's in the positive. Like right now, we are in the positive. Look how far north we went. That means the magnetic fields are going to be deflecting. They'll be pushing it away, and we could probably, source that out right here. Maybe not. This is magnetic pressure. I forgot to show you this one, but yeah, I mean, nothing real big is what I'm trying to say is happening at the moment. But we are getting hit. So I just want to make sure you guys know that. And that can flip in just a snap of your fingers, you know? Yeah, they're very fun, aren't they, Kristen? I mean, they really are. They do good music, good looping, good just comedy in general. Nacho is hysterical when she does her shorts. It really is. She makes me laugh every time. So, anyway. But we look for Aurora. Why do we see Aurora? Because, again, guys, the stuff was coming in on the poles. And when it gets down into our atmosphere and certain layers, it will excite oxygen and nitrogen molecules. Oxygen will typically put off this green, and then nitrogen usually puts off a red color. Those are your Aurora. That's why we have Aurora, guys, because we have solar wind and a magnetic field. Okay? So, just so you know. Alright, now, and what is this? X out of that. Okay, now these clouds, guys, people, when we see different kinds of clouds that we've never seen before, obviously it's going to be like, what in the world's going on? Right? Well, they fired a rocket, okay, and it went up, and because of the atmospheric conditions and stuff, it actually produced twisting clouds of trimethyl aluminum, TMA, clouds over Norway on November 10th, okay? And it was during a minor geomagnetic storm. It was the really low-level geomagnetic storm we had 2 or 3 days ago. Well, on the 10th, okay? And let's see here. Ivar Sandlin, he caught this picture here. That's in Narvik, a small town inside the Arctic Circle, right? So, yeah, so they fired this off. Now, it wasn't from, like, our typical blasting sites that you would think of. It was from Andøya Space Center in northern Norway. We oftentimes think over here in the United States that we're the only ones that have this stuff, right? We're not. I promise. Stuff is everywhere. It's like the particle colliders. Everybody goes back to CERN, right? The word I can't say because if we do, the video's done as soon as you say that word. But there's multiple particle colliders, high-speed particle colliders around the planet. So, yes, CERN is the most famous, and I'm not sure if it's the most powerful one, but if it's not, it's really close to that. So, obviously, that's what everybody talks about. But there's a bunch more around the planet, operating all the time. So, always keep that in mind when you're listening to somebody talk about that. Ask them about it when they talk about it, because they need to be, bringing that into the conversation too, because it's not the only one there. So, I'll just say that. Now, let's see here, 16 canisters, which were released in the upper atmosphere. Okay, So it wasn't a NASA rocket though, at least that's what it says here. Yeah. I'm not sure why, if that was some sort of fuel, or why they would put those there. Why they would release that, I don't know. But yeah, so come over here and read this at spaceweather.com. Dr. Tony Phillips does a great job with this website, guys. Go show him some love, give him some traffic over here. Look at this. Rush hour satellite traffic. Check that out. There are now more than 10,000, listen to this, 10,000 active satellites in Earth orbit. Wow. Okay, so why are we seeing the lines like this? You guys know why? These are the same. This is the same reason we see star trails. Well, partly, okay? It's because this isn't on the same plane as the satellite movement. These are long exposures, and what's happening is it's not following each individual satellite on its line of sight or its path. Because of that, we can't see exactly where it's at. This is why when you look up at the sky, you'll see the circle star trails. That's field rotation causing that. And if you don't have an equatorial mount on your telescope, you're going to get those, for long exposures, you're going to get those star trails. And the way to eliminate that is to get an equatorial mount. In other words, your telescope will automatically turn at the degree it needs to follow whatever star you're looking at. Okay, so you don't get that trail. That's how they do that. Okay, that's why things seem to appear to roll across the sky. The stuff up there is not moving. We are. And we're tilted. So keep that in mind too, in reference to the sun anyway. Okay, about 23.3, 23.4 degrees. That's our tilt. And I know that we talk about that tilt bouncing around, and yes, it does, but it doesn't go more than a degree or two over thousands of years. So, and if it does do something crazy, you're going to know it immediately. There won't be no question when it does happen. So, in other words, the number of daylight hours you see will instantly change if our tilt drastically changes, because that's what's determining your amount of daylight you see a day. Is the tilt. Okay? So just remember that. That's why we get seasons and all that. If you want to know if we've actually tilted so so much like a lot of people will talk about. Like, I'm talking like down to 90 degrees or 80 degrees. All you got to do is call up the tourist hotels inside the Arctic Circle that run their business and have had their business running for 50 plus years on 24-hour daylight and 24 hours of darkness. Why do they get that? Because of our tilt. If our tilt changes, guess what? They no longer get that 24 hours of anything. Everything across the planet would change. Everything. Not just in one area, the whole planet would change. Okay? So keep that in mind, guys. I mean, it's not hard to show either. It's really simple once you look at it. So I'll just say that. Now, again, too, guys, you know, we do get some tilt movement, and we do expect it. I think it's on like a 46,000 year cycle. And we get a little wobble, too. Eventually, Polaris will not be our North Star. They'll have to change it. And it may make its way back to Polaris because we're kind of wobbling a little bit. But the wobble they're talking about is not like massive amounts, guys. And it happens over thousands of years. So I want you guys to understand that. So if we see some big drastic change, it's not going to be, there won't be any question when it happens. There's not going to be. If our tilt changed, like a lot of people think, you know, we'll talk about, like massively, all the sundials on the planet would no longer work because the angle of the sun would be different. You could not no longer go outside, get lost in the woods, and use the stars to get out of the woods like you can today. Because everything would be in a different position. And I promise you, if you go outside and you go to the woods and you take a compass, you can find your way out by using the stars. That would not be possible if our tilt had changed in a drastic way. So keep that in mind. All right, guys? So, just saying. All those things would have to be explained, and they can't be. Not to mention, if we tilt to 90 degrees, guess what? That means in the summertime, the sun would never set for half of the planet. For 4 months. Okay? And the exact opposite side of the planet, guess what? The sun would never come up. What would that do? Do you guys understand what that would do? One side of the planet would freeze to death. The other side of the planet would burn up. And then in 6 months, those conditions would change. Do you think we would be here anymore if that actually happened? No, we wouldn't. So, I'll just say that. I'm going to leave that alone. All right. So, guys, so what do we got coming? Well, right now, ooh, look at that. See that right there? We bumped up there. We may end up getting to a geomagnetic storm here in the next hour or two. This is measured by the HP and the KP. The KP and the HP are basically the same indice. That's how we measure geomagnetic storms. But with that being said, these are 30-minute averages on this one. And these are 3-hour averages up here. Okay? So I'll be interested to see what this... Now this would be the official one. This is NOAA, Space Weather Prediction Center. So yeah. Alright guys, I think I'm going to go ahead and end it here, guys. I will definitely be back. I'm trying to get back to my regular schedule, guys. I'll be here every day, as much as every day as I can. If something happens big, you guys know that I stop what I'm doing and I come out here immediately. I do it a lot. Like when we get big X flares and stuff like that, I'll be here 2 or 3 times during the day. And thank you guys for, you know, understanding why I wasn't here for a couple days again after I had just taken a couple days off. I just had a lot of stuff. And again, guys, wasn't good stuff, a lot of it, but I'm not going to put that all out there because everybody else has got a lot worse stuff going on in their lives. And I just wouldn't even feel right complaining about it. You know what I mean? So, let's give some love over to Mist and everybody else that needs it. Let's get some more ones in that chat one more time before we get out of here. And just know, guys, we love you. And yeah. So, anyway, let's yeah. Okay. Oh, that sucks. Wrath, that sucks bad. I lost the tip of my left thumb. You're awesome. Hey, Harley, good to see you. Planet Hermit, you're awesome. Skywatch, you're awesome. Enlightened, hey, Ron, good to see you. You guys are all awesome. Just so you know. Hey, Kristen. All right, guys. I love all you guys. We had some big earthquakes, too, this past week. Again, get over and check out Ron. So, all right. I'll let you guys in with this image right here. And, again, guys, I know I had a lot to go over, but hopefully you guys enjoyed that a little bit. I tried to go a little deeper than I normally do every day, but that is what it is, and I just want to make sure everybody's got the right stuff. So, all right, guys. See you guys tomorrow. Look for anybody that's a member. Please turn your bell on. I will be doing one the next day or so. If I don't even do a regular live stream, I'm going to do a members-only stream. I got to get one out to you guys. We're going to have fun. I got some good videos lined up to show you. So we're going to react to some funny stuff. And, yeah, chiropractic and some Zoom court, all that stuff. So, anyway, God bless. Yahusha saves. And as always, you can drink this Kool-Aid.